Okay, let's look into next question. So here we have question 4, question 4. Okay, so given two functions, gx and then gfx, you now have to find f, right? So of course you can't just find f3 because you have to first find fx, and then you sub 3 into the x, and then you can find f3. That's the common thought process. Okay, so in this case you are given two functions, and now the thing is that most people tend to confuse between, like, because there are two different scenarios. If you are given gf, you might be given g, or you might be given f. The thing is that if you are just given g, it's quite simple to find f, right? Because yes, so because in this case you just have to you just have to let your x equals to fx, then you can find what is your fx. But if it is the other way around, that you are given f and then you are now given g, then what do you have to do? Yes, you have to kind of go the other way around. You have to find f inverse, so that you can sub the f inverse into f, so that f and f inverse cancel off each other, it becomes g. Something like that, okay? But in this case, it's quite simple because it's a very straightforward function that you are given the first function, the previous function in the front. So in this case, you just have to sub 5 plus 2. It was supposed to be x, but now as you know, you are doing gfx. So it's actually gfx, something like that. So this x corresponds to this x. So now this fx should be also mapped into this x. So it should be 2fx over 3 equals to 2 over x minus 1. Now just do a little bit of manipulation to move things around. So negative 3 minus negative 5 minus 5, so negative 8, and then divide by 2, so 3 over x minus 4. This is your value of fx. Now find f3. So f3, just substitute the x with 3, as simple as that. So 3 over 3 minus 4, negative 3. Let me just check with the answer, just in case. Okay, yeah, correct, negative 3. Okay, yeah, that's it for this question. Next question, we want to find, this is h inverse, we want to find h. So yes, this is very simple because no matter you are given inverse or you are given the actual function, you want to find the other half, it is always the inverse of each other. H and h inverse is always the inverse of each other. So no matter you are given the h or h minus 1, h power minus 1 is the same thing, because eventually you can also call this gx, and you want to find g minus 1x is also the same thing. Why? Because they are just the inverse of each other, nothing different. So yes, now we want to find the inverse. So in my way, what I usually do is that this is kind of like y equal to 4x minus 7. So now you want to find the inverse, right? So people will say you want to express x in terms of y. In my way, I will just swap them around. So x equal to 4y minus 7. This is your new equation for hx. So y equals to hx. Okay, yep. So this equation done. And then now just move things around. So y equal to x plus 7 divided by 4. Okay, yep. So please make sure you write it again. X plus 7 divided by 4. Okay, yep. Next question, so find p in terms of k if h minus 1, let me just annotate over here, so h minus 1 and then you do h again. This is really a silly thing because you want to find something, so let's say that like this, 7. You want to find something, so you want to find the hx of 7, so h7 is like this, equal to some other value. And then now you find the h inverse of this h7, which is the h inverse of a, which is basically returning the same root, become h. Yep. So what I want to say is that h equal h minus 1 or whatever thing, f inverse, whatever thing inverse of itself, it will just give back the same value. So it's nothing. It's just 1, or you can just ignore this entire expression. So this entire expression should be cancelled off. It will just actually give k plus 5 equal to hp. Now sub your value, so p plus 7 over 4. X here, so you put this p into this the value of x, okay, put into the location of x, that's it. And then so k plus 5 equals to p plus 7 over 4. What the one? P in terms of k. So again, move things around, and then you will eventually reach at this equation. Okay, yep, that's it for this question. Okay, 3, 2, 1. Okay, next question. Question 5. Okay, this is a bit weird. I mean, not a bit weird, but a bit unexpected, because it's kind of conceptual. But what is good? Yes, now you have a calculator. Just put in the calculator, test whatever value you want, and then you see which value can correspond to the range. Okay? Yep. The actual way it should be draw a graph. Log 10 graph should look like something like this. Yep. So you draw a graph and you know that this is 1. So as you can see, it wants a value when log 10 graph equals to less than 0. So it should be this region. So this region, it will actually correspond to this line, right? Which is actually this region of X. So they basically, your A, this is A actually, yeah. So your A should be less than 1, but then greater than 0. Yes, so that's it for this question. And the few things to know is that, yeah, remember to put the greater than 0 because the graph will never ever go beyond the point after 0. Okay, and also don't put the sign like this. This is wrong. As I said, 为什么 why? Okay, I'm sorry for the random Chinese. Yeah, so why? Because your graph, as I said, it can never ever approach 0. So this sign should not exist because it could never equals to 0. And also it cannot equal to 1 because when log 10a, when a equal to 1, so log 10 1 will actually give 0, and 0 is actually 0 is not. Okay, it's not less than 0. So in that case, you cannot fulfill the equation here. So only when the A it's smaller than 1, it cannot be smaller or equal, it must be smaller than 1, then you can get the entire log value smaller than 0. Okay, or else if you put it exactly at 1 position, it will give 0. And you can just test it out with your calculator so it shouldn't be any problem. So in your exam, right, what do? Yes, test with 3 different values. Test with positive value larger than 1, positive value smaller than 1, and then negative value, let me add another condition, negative value larger than negative 1, negative value smaller than negative 1. So just test this for out 0, 1, negative 1. So yeah, because this kind of question, right, it can appear in any kind of formula. It can give you like something like NCR and then ask you what is the range of n, and so on and so forth. It happens all the time. So in that case, if you're unsure of how does the graph look like, it's okay. Just go and test out these 4 values: positive larger than 1, positive smaller than 1, negative smaller than negative 1, and negative larger than negative 1. And after testing these 4, you should be able to find the 4 range. Okay, and you see which range will correspond to this range, this so-called range of data. Okay, yep, that's it for 5A. Next question. So yes, A equal to 7 power of X and then B equal to 7 power of Y. Now just simplify this entire thing into 7. That's it. So we know that 7 to square is 49. This is a key concept should be. So 49 X plus Y, it should be simplified into 7 square X plus 9. And you know that square can actually be expanded by just multiplying the index together, right? So it actually becomes 2 bracket X plus Y. So it will give 2x plus 2y. Yeah, okay, actually I can just do it. It's okay, whatever. Yeah, let me continue. So now you want to express this in terms of X and Y, in terms of just 7 power X or 7 power Y. So that's why you need to have a bit of manipulation here. Just make this into a multiply sign, and then again kind of a repeated process, but yeah, extract the 2 out. So now you get 7 power of X, 7 power of Y, and this is when you can just sub in your A and B here. So this is actually A squared B squared. Okay, this is done for the first expression, first term. Second term is fairly easier because it's just like this, and then you just do what? Yeah, you do the division, because we learned that A B minus AC will equal to A power of B minus C. Multiplication will become division. Division will become subtraction. Multiplication will become addition, right? So yeah, in this case, it's just actually like this, and then you simplify to A over B. So put everything together: A squared plus B squared. A squared B squared plus A over B. This is a final expression. Okay. Yep. 3, 2, 1. Okay. Question 6. Okay, this one, right? So yes, find the total population of bacteria A. This is just very easy because second there means n equal to 2 because it already says that n is the number of days, so n equals to 2. So just have to plug in n equals to 2 into this equation. A, right? You want A, right? So yeah, so 200 e power of 2. That's it. And press your calculator and you should get the answer. 1477.81. Okay, yep. Next question. After how many days the total population of both bacteria will exceed this number? So the total population, it always follow this equation, right? Because it's just a total of A and B. So the total of 200 en plus 220 e to the power of n plus 1 is greater than this number. Now let's simplify a bit. So we can see here, it's all divisible by 20, right? So divide by 20, divide by 20. This one divided by 20, 800,000 divided by 20, it gives us 40,000. So now let's simplify the equation further a bit because we see that this is 10 times e power of n, but this one is actually em times e1. Again, as I said, multiplication turns into addition in my index. So we can just split the index into en and e1. So we can actually, eventually we can factorize the en out. It becomes 10 plus e. Remember that e is our natural number. It has a value 2.7 something. So the value of e is countable. It's not unknown. At least it's not unknown. So yeah, now just move everything. En is greater than this. Yeah, usually I don't suggest to simplify first because it will just make your entire equation very long because the decimal place is very, it's very long decimal. So just put it in the so-called unknown form first, and then you convert it at the very end of the solution. So now how do we convert? How do we find n here? Yes, it's the same thing as imagine 10 power of n equal to 7.8. What do you do? Yes, you have to take the log of both sides. So n it could be greater than log 10 of negative. Is it correct? Is it greater or smaller? 10 power of, okay, log 10, let me just test it out. Log 10, okay, so 10 power of this, it should be greater. Yes, correct, yep. So something like that, yeah, that's it. So applying the same concept here, we also do the same thing. Basically, we have to do log e power of, log to the base of e and then e power of n. So that this one also log to the base of e. Yep. Okay. Yep. So that's why you can see over here our n get cancelled out. Our e get cancelled out. Log base of e and e will get nothing. So cancel out. You're left with like this. Base of e and then over 10 plus e. Okay, yep. Note that also, if you want to make it more professional, remember that log to the base of e is actually just ln. So it's actually just ln 40,000 over 10 plus e. Okay, now just put into the calculator ln to the power of ln and then bracket 40,041 over 10 plus e. You should be getting the answer n larger than 8.05. So if n must be larger than 8.05, and if n is number of day, it must be an integer, 整数, so whole number. So n minimum would be 9 days. Okay, yeah, that's it. So 3, 2, 1, okay. Should I start the recording or should I just continue first? Okay, let me just continue first. Okay, cool. Let's look into the next question. Question 7. So this is a study, and then it says that 2% of the packages do not arrive at the destination, blah, blah, blah. So what is the type of random variable? We have two types. We have discrete. Some people might call it binomial, but it's actually discrete and then normal. Okay, discrete distribution and normal distribution. So in this case, the key difference is that in a discrete variable, is what actually from biology we learn that something like discontinuous variation, it shows discrete, which is you have bar chart and then you have countable, you have measurable quantities, and normal is something like this where you have histogram and then you have non-measurable quantities. Okay, yep. So in this case, yes, discrete means that Discrete means that you can have each of the specific cases separated, and then you can go and calculate how much you can count. How many is this case? How many is that case? And so on and so forth. This is discrete. But normal is like you have a range of value. You have 40 kg, but you may also get 40.1 kg. You may also get 40.01 kg, and so on and so forth. It's like a continuously. You can't just find an exact value that shows 40 because there is always variation. Okay, yep. But for this one, why does it show discrete? Yeah, the answer is discrete, by the way. Why does it show discrete? Because it's countable. You can separate them into two cases. It's basically just arrive or not arrive. Right. So either you arrive or you not arrive. Either a yes or a no. So you can just count. 98 arrived. So count 98, and then this one to not arrive. Something like that. So that's to say this is countable because I think the answer used the term data. Is it? Yeah, let's just say data is countable. Okay, what is the case of uncountable? Now, let's say today I give you a question, I change a bit. I change it into 2% of the egg is less than 2 kg. Then you know that the phrase less than 2 kg, it suggests that it could be 1.998, 1.99. 1.999, it can be whatever value that is lower than 2 kg. So in that case, you can never find a very exact value that represent so-called less than 2 kg. You will always get a very, you get a spectrum, you get a distribution of the value all across the entire number line. So it's never like 1 and 2, something like that. But it's always like 1, and then inside this 1, between the 1 and 2, right, you get a lot of different value because of the nature of the number. Okay? Yep. Unless today I say something like how to say? Let's say you can say something like 2% of the participant win less than 7 times. In that case, it should be discrete. This is discrete. Why? Because as you can see, win less than 7 times. That means you can win 0 times, 1, 2, 3, 4, 5, and 6. But you could never win like 6.5 times, 5.4444, whatever thing. You cannot have random number. You can only have integer whole number 0, 1, 2, 3 until set 6. That's it. Yeah. So that's why in this case it should be discrete because you can separate all the data into specific column and you count them. Yeah. But in this case, for the kg, for something like length, mass, and so on, it cannot be separated into column because it's always continuous. You range from you can have a very little deviation. That's why in that case you should use normal distribution. Okay. Low battery. Wait. Okay, let me come back. So yeah, that's it for 7A. Oh my god, it's a bit messy, but yeah, let's look into 7B. So here you have a jewelry store and 2 out of 7 customers bought jewelry. So the probability is very obvious. The probability is 2 over 7. Okay, so out of 2 over 7 here, it says you have 10 customers, basically 10 samples. So out of the 10 samples, we want 4 of them to be bought. So again, in this case, it's discrete, right? It's discrete, right? Because it's either you buy or you didn't buy, bought or didn't buy. So it's very obvious. It's either yes or no. So discrete, yeah, it's either bought or not bought. So it's discrete variable. So what formula do we use? Yes, we use a formula NCR. I kind of remember also P and P power of R, I guess, and QR power of M minus R. If I remember correctly. Anyway, so the formula should go like this. So N is my total number of sample, and now I want 4 of the sample, 4 out of the 10 sample to be correct, to be successful, we call. So in this case, we know the successful rate, the probability is 2 over 7. That's to say the fail rate the probability of someone not getting the jewelry is 5/7. So in this case, R will be my 4, and then n minus R is 10 minus 4. So just work this entire equation out. You should. I'm lazy to work out the entire thing. So you should be getting the same answer, 0.1859. Okay. Yep. Another case. Now you want at most 2 of them did not buy jewelry. Let me phrase this one by one. At most 最多. Okay. At most 2 of them cannot buy jewelry. That's to say, at most 2 of them. So maybe it could be 3 different cases. 2 did not buy. 1 did not buy, 0 did not buy. Again, as I said, because this entire case is based on discrete distribution, so you cannot have 1.2, 1.3 because it's discrete. It's just whole number. It's either 2 people did not buy, 1 people did not buy, or 0 people did not buy. So in fact, all of these match a condition. At most, there can be only 2 of them did not buy. So either 2 or 1 or 0, it fits the condition. Okay, so now you have 2, 1, 0. And again, as we know, our percentage, our probability of success, we define them as bought jewelry. So if you don't want to confuse yourself between bought and not bought, it's kind of confusing to switch between the P and Q lah. Because you can also do something like you exchange the P and Q, so you make your P now 5/7, and then your Q is now 2/7. Basically, you switch the case of successful and fail. But I would not suggest that because I myself even get confused sometimes. So yeah, in this case, I would suggest just do a simple switching your statement such that you can know that if 2 of them did not buy, that means 8 bought lor. And same case here, if 1 of them didn't buy, so 9 will buy. And then this one is 10 bought. So that's to say, you just have to work out the number of, the probability of the case when 8 people bought, 9 people bought, and 10 people bought. You should be able to get the same result. Okay? Yep. So just make it into 3 statements. Let's say 8 people, 8 bought. It will be 10C8, 2 to the power 2/7, 8, 5/7, 2. And then if you want 9 bought, just take 10C9, 2/7, 9, 5/7, 1. And then you want 10 bought, it will basically be 10C7, 10C10, 2/7 power 10, and then 5/7 power 0. It's actually this one is nothing. It's just 2/7. Basically, you have 10 successful cases, so you just take 10 times the successful probability. So 10, this P, the successful probability, power 10. Yeah. So find out all the answer. I don't want to calculate out the actual value, but just work it out yourself, and then plus them together, you will be able to get 0.001114. Okay, just text me if you have any other question. Yep, so that's it for question 7, done. Question 8. So now you have okay, 8. So a school mathematics quiz competition, you have 15 participants. It says that you have to choose at least 8 girls. So again, you have 10 girls over here. You now have 8 girls. You have 10 girls to be chosen, and you want at least 8 girls. So again, you can see this can be separated into cases, right? Always try to separate your entire complicated situation into different cases, and then you work out the different cases and you plus them together. This is the easiest way to tackle this kind of long question in probability, in combination, and so on. So in this case, 10 girls, you want to take 8 out. So it could be 8 girls chosen. So 8 girls will plus 7 boys off because 15 you have to make up a total of 15. Okay? Or you can also have, let's say, 9 girls, because 9 is also at least 8. If anything greater than 8 will be called at least 8. So 9 girls plus 6 boys. Again, 9 plus 6, 15. Fit the condition. 10 girls plus 5 boys. Right. So now just work out each of the different combinations, and then you will get the final answer. Let me check. Yep. So let's say I want to choose what is the number of ways I can choose 8 girls out of 10 girls. Yes, 10C8. What is the number of ways I can choose 7 boys out of 8 boys? Yes, 8C7, and time them together. Remember, please don't put a plus sign here because it's always time. Why? Because for every specific combination of girl you choose, you have this many of specific combination of boy. Basically, you have so many ways to combine girl and so many ways of combine boy. So what will be the total combination? Yes, because for each of the girls combination, you have the corresponding entire set of boys combination. So it's definitely not plus, it's definitely multiply, because for each of the every C10C8, you will have a corresponding 8C7. That's why it's always multiplied. Okay, yep. Working the same thing out, so 8C6, this one is like this, 8C5. And again, I don't want to calculate the answer, you can just try to do it yourself, and your answer, just sum them up together, it should get 696. Okay, yep. I just see the answer and just print the value out. Okay, yeah, I don't want to do all the things out, so you can just try to work it out yourself, and if any question, just let me know. Okay, yep. Next question. So now we have 7 pearls and 6 bags. They are of different color and they are arranged using a different way. So for the pearls, you have 7 pearls, 1, 2, 3, 4, 5, 6, 7. You arrange them into a circle to make a bracelet. So like this, basically it's a circular permutation, right? Yeah. And then another side, you have 4 bags chosen from the 6 bags, and you arrange them onto a clip. Okay, onto a hair clip. So in this case, yes, I think it's quite simple. So in this case, basically you are trying to, this one is doing permutation, this one also doing permutation, right? Because all of them is position specific. It's not just choosing 4 of them, but after choosing 4 of them, right, you have to arrange them in a way that is different from one another. So it's always like there's a specific arrangement that gives a specific combination of the specific case. So this one you can do like a green, blue, red, red, or you can do like green, red, blue, blue. All of them are different. That's why in both cases is permutation. What is the difference here? The difference here is that this one is circular permutation. It can go around a circle and it will reduce the number of permutation by a lot, and this one is just a straight line, so it's just a string, and then it does not divide by anything because it's just an entire string. Okay, yep. So it asks you that the number of ways to arrange both of them, are they the same? Yeah. How to answer this? Yeah, don't go any theoretical stuff, just count the value, just calculate out the value. How much is this, how much is this, and then you compare. After that, if you are the same, then the same. Now as you can see, it asks you to verify using calculation, so just compare. If it's same, then it's same. If it's different, then it's different. That's it. Okay, yeah. So for 3A, you have 7 bags. So as we learned before, in the case of 7 bags, in the case of 7 stuff to be arranged in a circle, we know that the number of ways to arrange is the factorial of n minus 1. So it's basically 7 minus 1 factorial. And then in this case, we have to again divide by 2. Why do we divide by 2? Because this is a bag, and you know a bag, it can, this is a string of pearls actually, and it can be turned upside down. So how do I say this? So when you have a string 1, 2, 3, 4, 5, 6, 7, and you also have a string 7, 6, 5, 4, 3, 2, 1. Yeah, they look different because of the way they're arranged, but they're actually the same thing. Why? Because when you take this so-called circular pearl, the string of pearl, you flip them to the other side, you do a rotation like this, you will realize that it's actually the same as this thing. So that's why they seem to give 2 different combinations, but it's actually the same thing. So that's to say, for every of the combination calculated here, right, there's always inside this 6 factorial, 6 exclamation mark, there's always a set of 2. There's always set of 2 such that two of them will correspond to each other, and 2 of them will correspond to each other. So let's say today you get 1, 2, 3, 4, 5, 6, 7. It's actually the same as the inverse of it. Okay, so for every of the specific combination, so-called, I think it should be called permutation. Okay, for every specific permutation, you will have an inverse of it, because of the nature of this question is a string of pearl, and it can be flipped, and it can be 2-way. Okay, it can be read as 2 ways. So in that case, for every of the specific arrangement, you will have a different way of arranging it, which still gives the same result, provided you have to flip it. Yeah, you have to flip it, and then that's to say, this number 7 minus 1, 6 factorials, it actually gives the total number including both cases. So since we know that for each of the cases, it will have another case that is actually the same thing, then what do? Yes, we just divide by 2, because we know that the total number here, it will be double, because one case actually can be represented into two different permutation. One is upside down, one is vertically upright, things like that. So that's why you just divide by 2 and it will give the answer, it will give the same answer. So 6 factorial divided by 2, 360. Okay, yep, it should give the same answer. It should give this answer. Another side, simple, you just do 4. You have 6 stuff, right? You have 6 things to be arranged on 4 places. So 6p4, 6p4. You also get 360 is the same thing. Okay, sorry, it's the same. So yes, the answer, it should be equal. Okay, is equal. Yep, that's it for this question. Okay. Should I proceed with the next one? I mean, it's getting a bit long. So this is not hard. Okay, cool. So let's look into question 9. So now we have question 9 here, and the thing is that this is a bit tricky. This is a bit tricky because it gives you an unknown k. And throughout the entire thing, right, they don't need you to find unknown k actually. So what happened is that, you know that the so-called, this one, the vector PQ, it must point from P to Q. And the length of this vector, okay, since it's called PQ, it should be restricted to the length between PQ. In another word, the magnitude of this, okay, of this particular vector, it must be the distance between PQ. Because the vector is named PQ, so it can only go from P to Q. If you give me another something like this, yeah. So you cannot tell me that PQ is equal to RQ because although they are the same direction, they share the same direction, same parallel line, but then their magnitude is different. That's why they cannot share the same. Yes, they cannot share the same so-called same magnitude, or to say same vector, but they can share the same unit vector, because if you divide this entire thing with the magnitude, you should get the same thing. Okay, yep. So now just to be clear that since we cannot find k here, so we definitely cannot use this k to find the n, because one of the method usually people do is that you just have to find out because the way we form this equation, you know, right, is always, yeah, it's simple. It's just taking the what? Is just taking n minus 3, and this become our I, so it becomes something like this. But we can't do this here because it involves unit vector. So the easier way would be what? Yes, the easier way would be this equation where you take the magnitude equals to the length of PQ. So from this equation, we can easily see that what is the magnitude? The magnitude is 29, because the formula of unit vector is 1 over magnitude. Sorry, cert 29. So 1 over magnitude and then your vector here. Okay, yeah. So in this case, we can see that PQ is actually equal to cert 29. So what is the formula of PQ? The distance, right? Yeah, it's actually just Pythagoras theorem. It's actually just this distance and this distance. You do Pythagoras theorem. So it's essentially 10 minus 8 square plus n plus 3 n minus 3 n minus 3 square equals to 29 cert. So now cancel off the square root, you get 2 square plus n plus 3 square equals to 29. So n plus 3 square equal to 25. Neglecting negative cases, we take it only, it could be 5 or negative 5, but since as you can see, you can get 2 results. But negative 7 should be rejected because obviously in this case your n is x is now larger than 0, is positive. So you should give me 2 and reject the negative 7. Okay, and next question should be easy because it's just asking for OQ in column vector. What is column vector? X, Y, X on top, Y at bottom. So it's just simply n is 2, right? So 2, 10. Okay, yep. Let me check. Yep, that's the answer. Okay, so that's it for this question. Okay, cool. So, yep, that's it for this. Let me just stop it here. Okay.